Welcome to A-Level and AP Physics. In today's lesson, we will discuss typical type of questions on mechanics from Specimen Paper 1 for exams from 2022. In today's class, we are talking about Specimen Paper for 2022 and the total time for this paper is 1 hour and 15 minutes. If we go to the second page of this paper, we can find values of some very important constant. For example, value of G at AS level, you have to use 9.81 meters per second, and the speed of light in air and vacuum is also given. Charge on electron is given to you. 1 U means 1 atomic mass unit is given to you. Mass of proton is given. Mass of electron is given. Avogadro's constant is given. Molar gas constant is given. Boltzmann constant is given. Gravitational constant is given. Permittivity of free space is also given to you. Planck's constant is given, and Stephen Boltzmann constant is also given. So these constants are very important and their values as well. So maybe you will need them for some calculations in this paper. So if you need them, you can simply come back to second page and you can find the values of constants. On third page of this paper, you can also find some important formulae. The first one is about uniformly accelerated motion. Means when acceleration of the body is uniform. Or simply we can say when acceleration of the body is constant. Or even you can say that when acceleration of the body has just one value and acceleration is not changing with time, then we can use s is equal to ut plus 1/2 at square. We can also use v square is equal to u square plus 2as. S is the displacement, is not the distance. Displacement is equal to distance when the body is moving in a straight line. So you have to be very clear. S is displacement, not distance. Distance and displacement, they are equal in magnitude if the body is moving in a straight line. And the second one is for hydrostatic pressure, means delta P is equal to rho G delta H. Rho is the density of the fluid. Upthrust F is equal to rho G V. Rho is the density of the fluid and V is the volume of the fluid displaced. V is not volume of object in the liquid. V is volume of fluid displaced. Volume of fluid displaced can be equal to volume of the object inside water if the object is fully submerged inside the liquid, means it is fully inside the liquid. Then volume of fluid displaced and volume of object, they are equal. So you have to be very clear about this one. Let's go to next one. Doppler effect for sound waves. So this is formula for Doppler effect for sound waves. F naught here, this is the observed frequency. Fs is the frequency of the source. V is the speed of sound in that medium, and Vs is speed of source. Next one is for electric current. I is equal to A N V Q. This is also called transport equation. I is current, is cross-sectional area, N is the number density, mean number of free electrons per unit volume, or number of charge carriers per unit volume. V is drift velocity, and Q is the charge on single electron. Now you can say on single charge carrier. Next one is about resistors in series. Very basic formula. This is also given to you. The last one is about resistors in parallel. So this is for resistors in parallel. For question number 1, it is given to us a student creates a table to show reasonable estimates of some physical quantities. Which row is not a reasonable estimate? So if you look at the first one, option A, if you look at this one, this is about heater. And the power rating of a heater is 1600. Power rating is 1600 watts by 120 volts. Means the power is this one if the potential difference across heater is 120. And from here we can find out value of I. So this will be 1600, means the power divided by V. And this is approximately equal to 13.3 amps. And this value is close to this one. So this is a reasonable estimate. Simply this one is a reasonable estimate. Now if we go to option B, mass of a person 70 kilogram, average mass, this is also reasonable estimate. If we go to option C, maximum speed of an Olympic sprint runner 10 meters per second, this is also a typical value, means a runner, it can cover 100 meters in 10 seconds in 10 seconds. So the speed is about 10 meters per second. So this is also a reasonable estimate. Now from here simply we can see that D is the right answer. So this is not possible. So let's try to understand why this is not possible. P in this case is given to us. P is equal to 10 to 6 Pascal, but P is equal to rho GH, and in this case we are talking about water. P is given, so this is 10 to 6. So density of water, this is 1000 kilograms per cubic meter. G, for simplicity we can use this is 10. So here is H, so we can find out value of H means the depth, the value of depth we can find out from here. So H from here will be equal to 10 to the power of 6 divided by 10 to the power of 4. So this is equal to 10 to 2 meters, means 100 meters, very deep. This is talking about garden pond, so it cannot be 100 meters. It can be few meters, but not 100 meters. So this is not a reasonable estimate. So answer for this question is D. For the second question, we need to find out which expression has the same SI base units as pressure. So first of all, let's try to write down SI base units for pressure. Pressure is equal to force over contact area. Unit of force is Newton, but force is equal to MA. So we can write down SI base units for force. SI unit for mass is kilogram, and SI unit for acceleration is meter per second, and SI unit for area is meter square. So simply we can replace F and A with their SI units. So here we can write down kg, meter per second, and this is divided by meter squared. Now if we simplify this one, we can simply write down kg over meter. This meter, if we bring here, we can write down this is meter, and here we can write down this is second square. Now kilogram, this is unit of mass, so the quantity is mass, so we can write down mass here. Meter is unit of length, mean this is unit SI unit of length, so we can write down here, and second is SI unit of time, so we can write down time squared here. Now simply we need to compare this one with given options. If you look at option C, this one is correct option. For this question, it is given to us the speed V of a liquid leaving a tube depends on the change in pressure delta P and the density rho of the liquid. The speed is given by the equation, means by this equation. It is also given to us K is a constant and K has no units. We need to find out what is value of N, means what is value of this exponent. We need to find out. So now we need to understand if an equation is correct, it has to be homogeneous, and homogeneous equation must have same units on left side and also on right side. So let's try to understand this one with one very simple example. V is equal to U plus AT. If you look at V, means the unit of speed, final velocity, meters per second, and the unit of initial velocity is also meters per second, and unit of acceleration is meters per second, and unit of time is second. If we simplify this one, we can simply write down meters per second, and if we simplify this is also meters per second. Now you can see each term has the same unit, and units on left side and right side of this equation are the same. So this equation is correct and this is homogeneous. And so this equation is homogeneous. So this is the main concept we need to understand. Now let's try to apply this concept here. So simply we can write down unit for V first of all. So otherwise I can write down this equation again, as K has no unit. So let me rewrite just K here. So this one is delta P by rho to the power of N. Now we need to write down the units. Unit of speed is meter per second. K has no unit, and the unit of P we need to understand. P we have already discussed. This is force over area, so we can say its unit is kg, meter per second square, divided by meter square. So we can simplify this. This will be kg per meter per second squared. So mean this is SI base unit for P. So this is one thing we need to understand. SI base unit for P. We can also write down SI base unit for density, that is kg per cubic meter. Now simply we need to plug in these units. So for delta P, we can write down this is kg per meter per second square divided by kg per cubic meter. The power of this one is n. Now from here we can cancel this kg with this kg, so we can cancel out. I will be writing here, so let's move on to this side. Meters per second. From here we can simplify. You see the power of this one is -1. So if I rewrite this one, so we can write down, if I take this one to the numerator, so this will be plus and this one is -1 and this is s to the power of -2, and here we have power n. So we can further simplify this one, so we will write down here, this is meter square and this one is s to the power of -2 and the whole power is n. So we will take this one 2 here, so this is meter square, this is per second square, so the power is n. Now these two units have to be the same. So how we can make these two units same? If n is equal to 1 by 2. So simply if n is equal to 1 by 2, so then units on both sides are the same and this equation is, so n has to be 1 by 2. So the answer for this one is A. This is very common question and typical type of question. Concept is the same. Just follow step and you will be able to find the answer. For question number 4, we need to describe which row correctly describes the quantities, momentum, power, and temperature. So if you look at option A, momentum is scalar. Momentum is not scalar. Momentum is a vector. So this one is not correct. Power is scalar. This is true. Temperature is vector. This is not correct. Momentum is scalar. It is not correct. Power is vector. Not correct. Temperature is vector. Is also not correct. If you look at option C, it is given to us momentum is vector. It is true. Power is scalar. This is true. Temperature is scalar. This is also true. So the answer is C. If you look at option D, momentum is vector. It is true. Power is vector. No. Power is scalar. Temperature is scalar. This is true. So the answer is C for this question. So simply you need to understand momentum is vector, power is scalar because power is equal to work done over time. So it's a scalar. Temperature is also scalar quantity. When we talk about temperature or we talk about power, we need to talk about direction. So that's the reason power and temperature, they are scalar, but momentum is a vector quantity. For question number 5, it is given to us a ball is thrown vertically upwards. It takes a time of 3.20 seconds to return. It is also given to us, we can assume that air resistance is negligible for this question. We need to calculate initial speed of the ball. So first of all, let's try to sketch. Imagine that this is the ball. We throw this ball upwards with velocity u. So this is the initial speed of the ball. So this ball will go up, it will reach maximum height, and then it will fall down. Means it will come back. So it will come back at the same position. Means the initial and final positions are the same. As initial and final positions are the same, it means that displacement of the ball is equal to 0. Displacement is 0 because initial and final positions are the same. For this question, we need to calculate u, means the initial speed we need to calculate. But total time of flight is given to us, that is equal to 3.20 seconds. Acceleration due to gravity is equal to 9.81 meters per second per second. Now we need to assume one direction as positive. So in this case, we will assume upward is positive. So we are taking upward direction as positive because we need to find initial speed, and initial speed is upwards. If we take upward positive, it means our answer will be positive. But also we need to understand acceleration due to gravity is always downward. So acceleration due to gravity is downward because force of gravity is acting downwards. Acceleration and resultant force, they are always in same direction. So that's the reason acceleration is downwards. As we have taken up is positive, so acceleration has to be negative because it is in opposite direction. Now we need to understand acceleration is also constant and it is uniform. So simply we can use s is equal to ut plus 1/2 at square. Displacement in this case is equal to 0 because initial and final positions are the same. So displacement of the ball is equal to 0. We need to find out initial speed, but the total time of flight is given, that is 3.20 seconds. So we can write down plus 1/2. A in this case is negative 9.81 and time is 3.20 second square. Now if we solve this one for u, our final answer will be 15.7 meters per second, and this is positive. It means initial speed is upward, mean initial velocity direction is upwards. So our answer for this question is C. For question number 6, it is given to us a radio controlled toy car travels along a straight line for a time of 15 seconds. The variation with time t of the velocity of the car is shown here. So you can see on y-axis we have velocity and on x-axis we have time. Question is asking us, we need to calculate average velocity of the car for the journey shown by the graph. So the first thing we need to understand is, what is average velocity? V average is simply equal to the total displacement of the car divided by time taken. Total displacement divided by time taken. Now if you look at VT graph, we also need to understand area under VT graph is equal to displacement. So simply we can say area under VT graph, this is equal to displacement. Area under VT graph is equal to displacement. So simply I will write down DISP. So area under VT graph is equal to displacement, and displacement is a vector quantity. So we can say displacement is a vector quantity. If you look at this area from T0 to T10, this area is positive. So it means displacement is positive. And this area is equal to 30 meters, means 3 times 10. So this is positive. If you look at this area, this is negative. And in this case, we have 6 times 5. So this is equal to negative 30 meters. So the net displacement in this case is 30 minus 30 meters divided by time taken. And the total time taken is 15 seconds. So our final answer is 0 meters per second. In this case, average velocity is equal to 0 because the net displacement is equal to 0. So the answer for this question is B. For question number 7, it is given to us the acceleration of free fall on Pluto is 0.66 meters per second per second. It is also given to us the weight of the object on Earth is 6.0 newtons. We need to find out what is weight of the object on Pluto. So the first thing we need to understand, the value of G on Pluto is very small as compared with value of G on our planet. So it means the weight of the object on Pluto will be very small as compared with weight of the object on Earth. So this is the first clue, first thing we need to understand. So it means that answer cannot be C, answer cannot be D. So simply you can ignore these two options. So the answer is A, our answer is B. And the second point we need to understand, the mass of the object remains same. It doesn't matter wherever the object is in this universe. Mass does not change. So first of all, we need to find out the mass. So we will talk about Earth, means when the object is on Earth. So we can find out the mass. Mass will be equal to weight of the object divided by the value of G. In this case, we have weight that is equal to 6.0 newtons, and we need to divide by value of G, that is equal to 9.81. So you have to use 9.81, not 10. So if we divide by 9.81, our answer will be 0.61233. So this is the mass of the object. Now we have the mass of the object, so we can find out weight of object on Pluto because we have value of G on Pluto. So I will simply write down here W for Pluto. So this is simply equal to M times G on Pluto. So this is G on Pluto. Mass we have, this is 6.12 kgs. We have to multiply with acceleration, so that is 0.66. If we solve this one, our final answer will be 0.404 newtons. So the answer for this question is A. For question number 8, it is given to us a stationary firework explodes into 3 pieces moving in the same plane. The masses and velocities of the 3 pieces just after the explosion are shown in this figure. So as you can see here, we have one piece mass is equal to 100 grams, and the other 2 pieces the mass is equal to 50 grams and 50 grams. And the velocities are given and angle is also given. Question is asking us, we need to calculate what is value of V1 and V2. For this question, we need to understand, in the question it is given to us that just after the explosion. So it simply means that in this case, no external force is acting on the system. As there is no any external force acting on the system, system, so we can use law of conservation of momentum. And this momentum is in two directions, so we have to consider momentum in two dimensions. We need to consider momentum in two dimensions to calculate v1 and v2. First of all, we will consider momentum along horizontal, and we will take to the right as positive. So simply we will say initial momentum of the system has to be equal to final momentum of the system along horizontal, means along x direction. In this case, initial momentum means along x direction is equal to 0 because this firework, it was at rest, it was stationary. So P initial is equal to 0. Now, if you look at momentum of this piece along horizontal, mean along x direction, so this is positive. So we can simply write down 50 gram, we will be using G here, times V2 cosine of angle 60 degrees. Now if you look at momentum of the piece 1, so the momentum of this one means the velocity is to the left, so we will take this one as negative because we have taken to the right positive. So the momentum of piece 1 is 50 gram V1 cosine of 60 degrees. From here simply we can say that 50 gram V1 cosine of 60 degrees, this is equal to 50 gram V2 cosine of 60 degrees. We are just using mass in grams because it will be cancelled. So in this case now you can see 50 gram we can simply cancel with 50 gram. Cosine 60 we can cancel with cosine 60. From here we can find out V1 is equal to V2. So this is one point we need to understand. V1 is equal to V2. Now let's consider momentum along vertical, means along y-axis. As there is no external force acting on this system, it simply means that momentum along vertical is also conserved. And we will take momentum upwards as positive. So that's the reason I have drawn this arrow. It means upward momentum is positive. So we will start from here again. Initial momentum of the system along vertical has to be equal to final momentum of the system along vertical. Initial momentum of the system along vertical is equal to 0. So we have to consider final momentum. Final momentum also has to be 0. So we have three pieces. So piece 1, it has momentum along vertical. So we can write down its momentum is equal to mass of piece 1. We will be using mass in grams because mass will be cancelled. We no need to convert into kilograms. But if you want to convert into kilograms, you can also convert. Result will be the same. So I'm using mass in grams. So I have written 50 gram mass of this piece. And the velocity component along vertical is V1 sine of 60 degrees plus momentum of second piece along vertical. Mass of second piece is also 50 grams and the velocity component along vertical is V2 sine of 60 degrees. Now if you look at momentum of 100 grams, its momentum is downward, so we will take this one as negative. So we can write down the mass of this multiplied with its velocity. Velocity is negative, downward is negative. Now we need to simplify. As V1 is equal to V2, so we can replace V2 with V1. So we can write down 50 V1 sine of 60 degrees plus 50. I will replace V2 with V1. So we can say 50 V1 sine of 60 degrees minus we have 800. Now you can see this is 50 V1 sine of 60, 50 V1 sine of 60. We can take this 800 on other side. So I will write down 800 here. So this will be positive. So we can multiply this one with 2. So we can say 2 times 50 V1 sine of 60 degrees. Simply we can say this is equal to 100 V1 sine of 60 degrees. But we need to understand sine of 60 degrees is equal to root of 3 by 2. So we can write down here this is 100 times V1 root of 3 by 2. And this 2 we can cancel with this one. So we got 50 here. Now we will simplify this one for V1. If we simplify this one for V1, our final answer in this case will be 800. So this is 800. This is divided by root of 3 times 50 times 50. And if we solve this one, our final answer will be 9.2. So this is value of V1. But V1 is equal to V2. So it means it is equal to 9.2 meters per second, because V1 is equal to V2. So V2 is also equal to 9.2 meters per second. So the final answer is B for this question. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important past paper questions on mechanics from Specimen Paper 1 for 2022 exams. For question number 9, it is given to us an object is dropped at time t is equal to 0 from a high building. A resistance is significant, means we cannot ignore effects of A resistance. Graphs are plotted against time. The first graph is for the height of the object above the ground, and the second graph is for the speed of the object, and also we have plotted graph for the magnitude of the resultant force on the object. First thing, it is given to us object is dropped. If it is dropped, it means initial speed is equal to 0. So this is the first point we need to understand. Now if you look at the motion of this object, let's say this is one object. When we drop this one at this point, this initial speed is equal to 0, and the force acting on this object is only its weight. So W is equal to mg. So the acceleration of this one at this point, A is equal to g, because the resultant force only acting on this object is the weight of the object. But as this object will fall down, means it will move downwards, gravity will not change, W will still stay same, W will be equal to mg, but A resistance will start to increase. So this is A resistance. It will increase with speed. And when finally object has reached terminal velocity, so simply we can say W is equal to mg. When object has reached terminal velocity, then A resistance, this will be equal to weight. So simply we can say at that moment when F net is equal to 0, means when mg minus A resistance, this is equal to 0. So simply again I will write down F net here. When F net is 0, it also means that acceleration of the object is equal to 0. So this is very important point. Now we also need to understand, if we have a graph for velocity against time, means VT graph, gradient of VT graph. For VT graph, gradient is equal to acceleration. So this is the first thing we need to understand. For VT graph, gradient is equal to acceleration. So when body has reached terminal velocity, gradient has to be 0. So if you look at this graph now, you can see first of all velocity is increasing. But if you look at the gradient of this one, it is decreasing. And finally, gradient is equal to 0. So it means this is velocity against time graph. So simply we can say this is VT graph. Now we also need to understand, when object has reached terminal velocity, F net has to be 0. So at this point you can see its gradient is 0, means it has reached terminal velocity. So if I draw this dotted line, you can see at this point F net has to be 0. So this graph you can see F net is equal to 0. So it means this graph is for resultant force against time. So simply Z in this case is representing speed of the object. So Z is representing speed of the object. So this is true or this is true. X is representing F net. So this one is true. And Y is the height of the object above ground. Means object is still falling. So this is for height. So this one is for height. So our answer for this question is C. So this one is the answer. For question number 10, it is given to us an object hangs by means of two cords around two rods as shown in this figure. Weight of the object is given and weight of object is equal to 10 newtons. It is also given object is held in equilibrium by the forces F1 and F2. This force is F1 here and this force is F2. It is also given to us that the friction between the cords and the rods is negligible. We need to find out which row of the table gives an angle theta of 90 degrees. Means the value of this angle is 90 degrees. When this theta is equal to 90 degrees, we need to find out the forces, magnitude of forces F1 and F2. So the first thing we need to understand is, as the weight of this object is 10 newtons, so the vector sum of these two forces has to be equal to 10 newtons. Before we answer that one, first of all, look at tension in these strings. As this object is not moving down, it means there is a tension upwards. So we can say tension in string 1, let's say this is T1. It simply means that T1 is equal to F1. So here is also tension in the string, so we can draw tension like this. If we look at this second string, as this object is not falling down, so we can say the tension in the second string is T2. So F2 has to be equal to T2 because this object is stationary, so there is no resultant force. So we can also draw here tension, this is T2. Now simply the vector sum of T1 and T2, it has to be equal to 10 newtons. So we can draw here. So this one is T1, so this is T1, and if I draw T2 from here at angle of 90 degrees, so this one is T2, and angle between T1 and T2 has to be 90 degrees. So the vector sum of T1 and T2, so let's say this is the vector sum, it has to be equal to 10 newtons. So simply we can say vector sum of T1 plus vector sum of T2, this one has to be equal to 10 newtons. Or simply we can say T1 square plus T2 square, means the magnitude, this one has to be equal to 10 square. So this is what we need to understand. Now we can look at these options. If you look at option A, for option A you can see T1 is 4, so this is 4 square plus 6 square. This one has to be equal to 10 square, but this is not equal because 4 square is 16 and 6 square it is 36. It has to be equal to 100, but this is not equal. So it means option A is not possible. So we can just cross this one. B is also the same, so B is also not possible. So the answer can be C or answer can be D because 6 square plus 8 square, this is equal to 10 square. So this is true. So the answer can be C or answer can be D. Now let's try to find out which one is the right answer. C is the right answer or D is the right answer. For that purpose, we need to look at horizontal components of T1 and T2. Let's say this angle is theta 2 and the angle of T1 with horizontal, let's say this one is theta 1. In this case, simply you can see that as this object is in equilibrium, it is not moving along horizontal, it is not moving along vertical. So it simply means that T1 cosine of theta 1 has to be equal to T2 cosine of theta 2. But you can see from this figure, it is very clear that theta 2 is greater than theta 1. You also need to understand, if angle is bigger, it means cosine of angle will be smaller. So the cosine of theta 2 will be smaller than cosine of theta 1. As cosine of theta 2 is smaller, so the T2 has to be greater than T1. Or simply we can say F2 has to be greater than F1. So F2 has to be greater than F1. So the answer is C. Now let's try to understand this question with the help of animation. As you can see here, in this case, I have already set this angle 45 degrees and this angle also 45 degrees. If this angle is 45 degrees, it also means that the angle with horizontal, let's say this angle is theta 1. This also has to be 45 degrees because alternate angles are equal. So this angle, let's say this is theta 2, this one also has to be 45 degrees because this angle is 45. Now you can also see this object is at the center. So if I simply draw a line here, you can see this object is at the center when the angles are the same. We can also look at the forces. If you look at the forces, these forces means the T1, this is 7.1 newtons, and this force T2 also 7.1 newtons. So simply we can write down, I will be writing some important points here. If theta 1 is equal to theta 2, T1 has to be equal to T2. Let's try to understand a little bit more about this concept. So we will do some practice. I will be asking you some questions. First of all, if I increase this angle theta 2, let's say I make theta 2 equal to 60 degrees. So I change theta 2 to 60 degrees. Now can you guess which way this mass will go? This mass will go to the right, or this mass will go to the left. So you need to guess this one first by yourself. It will go to the right or it will go to the left. Take some time and answer this question first by yourself. And then I will change the angle and I will show you which way this mass will move. Let me change the angle now. If I make this angle 60 degrees, you will see this object will move to the right. So it has to move to the right. So you have seen this has moved to the right. So now we can write down here, if theta 2 is greater than theta 1. So now you can see this angle is greater than this angle, then theta 1. You can also see that T2 is greater than T1. So we can write down here, T2 has to be greater than T1. Let's try to understand a little bit more about this one by changing angle. Now you can see here, if I increase this angle, you will see this will go to the right. If I increase this angle, this will go to the left. So this will go to the left. Decrease this angle, it will also go to the right. If I increase this one, this will go to the left. You can understand from here, if I decrease this angle, it has to go to the left. So this is the concept you need to understand. I hope it is clear to you now how to handle this kind of problems. For question number 11, we need to find out which force is caused by a difference in hydrostatic pressure, and that force is upthrust. So let's try to understand a little bit more about upthrust. Imagine that we have a fluid inside this container and an object is placed here. So we can imagine that object is placed here. So this one is our object. On this object, there is a force acting in upward direction, and that force, what we call, is upthrust. So in this case, there is a pressure acting on this object P1, that is here, and there is also pressure acting on this one, that is P2. Upthrust, this is equal to the difference between these two, P1 minus P2 multiplied with the cross-sectional area of this object A. Simply we can say this is equal to delta P times A, and delta P is equal to rho G delta H times A. But if you look at A times delta H, this is equal to volume of this object. So simply upthrust is equal to rho G V, and V is the volume of fluid displaced. So we have to be very clear. This is volume of fluid displaced, but in this case volume of fluid displaced is equal to volume of object, volume of fluid displaced, and rho is the density of fluid. So this is density of fluid. So the main cause of upthrust is the difference in hydrostatic pressure. Means the value of E at the bottom is different than the value of P at the top. In this case, P1 is greater than P2. So that's reason upthrust is in upward direction. So this is always in upward direction. So the answer for this question is B. For question number 12, it is given to us a car of mass 1400 kilograms is traveling on a straight horizontal road at a constant speed of 25 meters per second. The useful output power from the car engine is given, that is equal to 30 kilowatts. It is also given to us the car then travels up a slope at 2 degrees to the horizontal, as you can see here, 2 degrees from the horizontal, maintaining the same constant speed. So you can see here speed here is 25 25 meters per second, and speed here is also 25 meters per second, and this speed is constant. Question is asking us to calculate what is the useful output power of the car's engine when traveling up the slope. First of all, let's try to understand what is meant by useful output power. Useful output power simply means that it is equal to total work done by car engine against external forces. Total work done by car engine, simply we can say total work done by car engine against external forces. I will simply say against external forces per second. External forces per second. So that is the P output, means the useful P output of car's engine. So very important point. This is what we need to understand. Now if you look at case 1, I will say this is case 1 and this one is the second case when the car is on the slope. When the car is on horizontal road, in this case there is a force by the car engine, that is the forward force. We can say that is the driving force. We can say this is T1, and there are resistive forces due to air resistance and also due to friction. So we will combine these two forces. We will simply say resistive forces. So we will simply write down the sum of friction and air resistance is equal to Fr. So in this case, Fr is equal to D because the speed of the car is constant. For this question, power is given. So we can say P is equal to F resistive forces times V, because Fr is equal to D1 means the engine's force. So we can find out Fr from here. So this is sum of resistive forces. P in this case is given. This is 30 kilowatts. So we have to multiply with 1000 and we can divide by the speed of the car. So our final answer in this case will be equal to 1200 newtons. So this is sum of resistive forces, means sum of friction and air resistance. Now if you look at the second case, as the speed is constant, surface is the same, it means resistive forces are still same. So we can say Fr in this case is also equal to 1200 newtons. But as this car is climbing up, is traveling up along the slope, there is also component of the weight that is trying to oppose the motion of the car. Then that force we can say is mg sine of 2 degrees. We can also understand this one by drawing this inclined plane. So this one is over car and gravity on this car is acting down. So this one is the gravity. If this angle is 2 degrees, this angle also will be 2 degrees. So this component of gravity or weight of the car, this is 2 degrees. So this one is 2 degrees. If this is mg, so this one is mg sine of given angle, means 2 degrees. And this is opposing the motion of the car. So mg sine of 2 degrees. Now from here we can find out the driving force. Now there are two forces on this car. One is Fr and the second one is mg sine of 2 degrees. So we can find out driving force means the force exerted by the car engine. Let's say that is equal to D2. And so D2 in this case, we will simply say D2 minus Fr and minus mg sine of 2 degrees has to be equal to 0 because the car is still traveling at constant speed. So from here we can find out D2. Fr, this is equal to 1200 plus mg. M is 1400. This is mass of the car and g is 9.81 sine of 2 degrees. If we solve this one, we can find out the value of the force, that is equal to 1679 newton. So this is the value of the force exerted by car engine. Now we need to find out P. So the P, useful power output by car engine, will be simply equal to D2, the force exerted by the car engine times the speed. Force is 1679 79 newtons. We have to multiply this one with 25. So our final answer in this case is 42 kilowatts, and this is right answer. It has to be greater than 30 kilowatts because there is an external force, means extra external force is acting against the motion of the car. So the power output has to be greater because the car is doing more work against external forces. So this one is not possible at all, so we can cancel. This is the best possible answer, so this is the right answer. For question number 13, it is given to us the diagram shows 4 forces applied to a circular object, as you can see here. For this question, we need to find out which O describes the resultant force and resultant torque on the object. So first of all, we will look at forces. We will be talking about vertical direction first. So along vertical, we can write down net force. If you look at forces acting along vertical, we have 2 forces, 45 newtons. Here we also have 45 newtons. One is up. If we take up is positive, so this force will be positive and this force will be negative. So sum of these 2 forces is equal to 0 newtons. Now we will look at forces along horizontal, and we will take to the right positive, and we will take to the right positive. So if we look at forces along horizontal, so again we will write down net force. You can see these 2 forces are acting to the right, and we have taken to the right is positive. So sum of these forces is equal to 60 newtons. So it means resultant force is not equal to 0. So the answer will be A. Our answer will be B. Now let's try to find out the resultant torque. So we can write down here net torque. If you look at this force, so the torque due to this one will be clockwise, but the torque due to this one will be anti-clockwise. So the net torque due to these 2 forces will be 0 because the same amount of forces and they're acting at the same distance from the center. So the net moment due to these 2 forces will be equal to 0. So the torque will be 0 due to these 2 forces. Now if you look at 45 Newton forces, these 2 forces, they form a couple. So the net torque due to 2 forces, we can simply find out that will be 45 times the distance between these 2 forces, and the distance will be equal to the diameter of this circle. So I will say diameter is d. So the net torque is also not equal to 0. So answer for this question is A. So in this case, the net torque will be clockwise. So the net torque will be clockwise, and it's not equal to 0. So non-zero resultant torque and resultant force is also non-zero. For question number 14, it is given to us a uniform horizontal footbridge is 12.0 meters long and the weight of the bridge is 4,000 newtons. It rests on 2 supports X and Y as shown in this figure. A man of weight 600 newtons stands at a distance of 4.0 meters from support X, as you can see here. We need to find out what is the upward force on the footbridge from support X. Means we need to find out what is value of this force. I will simply say this force is Fx. We need to find out what is magnitude of this force. For this question, it is given to us, it is a uniform bridge. It means the weight of this bridge is acting at its midpoint. So we can draw here. So this is the weight of the bridge, and the weight of the bridge is given is equal to 4,000 newtons. It also means that the distance from this side, this is equal to 6.0 meters. If you look at support Y will also exert a force on this bridge in upward direction. So this is also normal reaction force from this support. We can say this force Fy. The person is standing at a distance of 4 meters from X. So there is a force acting on this person in downward direction. So we will say this is the weight of the person. And weight of the person is equal to 6 600 newtons. So the weight of the person is given. So there is a force on the beam. So this is the force on the beam that is acting downwards, and this is equal to 600 newtons. We are talking about forces acting on the beam. So that's the reason the force acting on the beam in downward direction is equal to 600 newtons, and this is equal to weight of the object. You need to understand, gravity is pulling this person down, and this bridge is pushing this person up. So it means this person is pushing down on the bridge with this force. Simply you can understand this force is equal to weight of the person. So that's the reason I have written this is 600 newtons. Now we need to decide our pivot point. In this case, we will take moment about y, because we need to find x. If we take pivot about y, then we no need to worry about fy. So let's take moment about y. So we can say by taking moment about y. So simply we can say by taking moment about y. If we consider the moment due to fx about y, this will be clockwise. So this is due to fx. So we can say clockwise moment in this case has to be equal to counterclockwise moment. Clockwise moment is due to fx, so we can say this is fx time its distance from the pivot, and its distance from the pivot is equal to 12 meters. Now if you look at moment due to the weight of the person, means due to this person, this is counterclockwise, and moment due to the weight of the bridge is also counterclockwise. For the person, force is 600 times its distance. So this is 4, this is 12, so this one has to be 8. So it is 8 plus due to 4,000. So we can write down 4,000. Distance of this force from the pivot is 6. Now simply we need to solve this one for x. So if we solve this one for fx, we can find out value of force exerted by this support x. So multiply by 6. This has to be divided by 12. So our final answer in this case will be 2,400 newtons. Means this is the force exerted in upward direction by support x. So the answer is C for this question. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some very important past paper questions on mechanics from Specimen Paper 1 for 2022. For question number 15, it is given to us a metal block has a mass of 750 grams. Magnesium makes up 60% of the mass, and the remaining 40% is copper. Density of the magnesium is given, and this is equal to 1.7 gram per cubic centimeter, and density of copper is also given, that is equal to 9.0 grams per cubic centimeters. We need to find out what is density of the block. Now first of all, let's try to understand how we can find out density of the block. So simply I will write down here density of block. In order to find density of block, we need mass of the block, means the total mass of the block, and this one we have to divide by volume of the block. Very simple concept. Density is equal to mass over volume. But for this question, mass of the block is given, so simply we can write down mass of the block is 750 grams. We will use here grams because our answer has to be in grams per cubic centimeter. So for the mass, we can use unit grams. And this one has to be divided by volume of the block. Now this is the point we need to find out. We need to find out volume of the block. So how we can find out volume of the block? In order to find volume of the block, we need to understand volume of block in fact is equal to volume of copper. We can write down is equal to volume of copper plus is equal to volume of magnesium. I will be writing here Mg, the symbol for magnesium. Now how we can find out volume? Volume will be equal to mass. For example, if you need to find volume of copper, we will divide mass of copper divided by density of copper. So let's write down here mass of copper. We can simply say volume is equal equal to mass of copper divided by density of copper plus volume of magnesium. So this will be equal to mass of magnesium divided by density of magnesium. Now simply we need to plug in values. Mass of copper, it is given to us 40% masses, means 40% of the mass of the block is mass of copper. So it simply means that 0.40 means the 40% of the mass of the block is mass of copper. So that's the reason you need to multiply with 0.40. And this one we have to divide by the density of copper. Density of copper is 9.0 grams per cubic centimeters. And the mass of magnesium. Magnesium makes up 60% of the total mass. Means 60% of the mass of the block is mass of magnesium. So we will be multiplying total mass with 0.60. So this is multiplied by 750 divided by density of magnesium, that is given here. And so this is density of magnesium. So we can simply divide this one by 1.7. Now if we solve this one, we will get, this is our value of volume of copper. And if we solve this one for volume of magnesium will be 264.7. So the total volume we can find from here, means the volume of the block, that will be 298.0 cubic centimeters. So this is cubic centimeters. Now simply we have to divide here. So this is 298.0 cubic centimeters. You can write down the unit here. Now if we solve for density of the block in this case will be equal to 2.51 grams per cubic centimeters. Up to 2SF we can simply write down. This is 2.5 grams per cubic centimeters. So this is our final answer. So option A is correct for this question. So you need to understand the approach. It's very important. The method, the way you approach problem is very important. For question number 16, it is given to us, a man climbs slowly at a steady speed to the top of a ladder. What is the main energy transfer taking place for the man as he climbs? For this question, it is given to us, the person is climbing at a steady speed. So if the speed is steady, it means speed is constant, means V is constant. So first thing we need to understand is that steady speed means that speed is constant. If the speed is constant, it means that the change in kinetic energy is equal to 0. It simply means that kinetic energy initial, kinetic energy is equal to kinetic energy final, means no change in kinetic energy. Let's try to understand this one with the help of these steps. So I will draw these steps. So you can imagine that this is the ladder. So you can imagine it like this. Now imagine that person started from this point. So this is the base. At this point, person has certain speed. Let's say speed of the person is u at this point. The speed of the person is u, and the person is walking this way. And when person reaches the top of the ladder, at this point, this is the top, speed of the person is still u. So if you want to write down kinetic energy at this point, kinetic energy initial, you can say this is equal to 1/2 mu square. M is the mass of the person. Let's take the base of this ladder as our reference line, or you can say reference level. And at this point, we are assuming that gravitational potential energy of the person is equal to 0. So the initial GPE of the person is equal to 0. And when person is at the top of the ladder, we can also write down the total energy of this person. So we can say E total will be equal to kinetic energy final plus mgh. Or simply we can say kinetic energy final is equal to kinetic energy initial plus this is mgh. Now if we compare energy of the person at the base and at the top, you can simply see that energy of the person has been increased. Meaning person has gained gravitational potential energy, but the kinetic energy is the same. So kinetic energy at the base and at top is the same, but gravitational potential energy of the person has been increased. So this increase in gravitational potential energy actually is coming from the chemical energy inside the body of the person. So this this increase in GPE is coming from chemical energy inside the body of the person. So if this person climbs many times to the top of the ladder, this person will get tired because this person is consuming chemical energy. In this case, simply we can say that the person is converting chemical energy into GPE by climbing this ladder, and that's the point we need to understand. So the answer for this question is chemical potential energy to GPE, gravitational potential energy. So in this case, simply, very simple question. Simply you need to understand GPE has been increased. So in this case, chemical energy of the person has decreased, and that chemical energy has been converted into GPE. So the answer is A. For question number 17, it is given to us a bead is released from rest at point P and slides along a wire as shown in figure. So this is the bead. We release this bead from point P. At this point, the bead was at rest. So the initial speed of this bead is equal to 0. We can also say its initial kinetic energy is also equal to 0. It is also given to us at point Q, the speed of the bead is 1.4 meters per second, and the height of the bead, we can say this is h. Height of the bead, this is also given, that is 40 centimeters. We can say this is h1 because this h is already here, so we can say this is h1. It is given to us in this case air resistance and friction on the wire are negligible. So friction and air resistance are negligible, so it simply means that mechanical energy is conserved. So this simply tells us that in this case mechanical energy is conserved. So we can simply say mechanical energy is conserved. Very important point. Mechanical energy is conserved. So later I will explain what exactly is mechanical energy. So mechanical energy is conserved for this question. We need to find out what is the height h from which the bead is released. Simply we need to find out what is value of this h. So simply we will use conservation of mechanical energy, and mechanical energy is equal to the sum of kinetic energy and gravitational potential energy. Sum of these two energies is equal to mechanical energy. So simply we can say in this case mechanical energy is conserved, so we will say kinetic energy initial plus GPE initial in this case has to be equal to kinetic energy final plus GPE final. Kinetic energy initial is equal to 0, so simply we can say this is equal to 0, and imagine that mass of this bead is m, so we can simply say this is mgh. Kinetic energy final will be equal to 1/2 mv square plus mgh1. So h1 is this height. Now simply we can plug in values and we can find out our final answer. One thing you can see here, m is common, so mass we can simply cancel. So this m we can cancel, so all these m we can cancel. We left with h, so we need to find out h. So this simply means this is v squared divided by 2 plus we have this is gh1, and this whole is divided by g. If we further we want to simplify this, we can write down this will be equal to v squared divided by 2g plus we have h1. Now simply we need to plug in values, so v squared I will be writing here. V squared means the speed at this point we have, that is equal to 1.4, so this is 1.4 squared divided by 2g, 9.81 you have to use at ES level, plus h1 is 40 centimeters, so simply we can say this is 0.4 meters. Now if we solve this one, our final answer will be 0.49 meters. So C is the best possible answer. For question number 18, it is given to us a mass is raised vertically. In time t, the increase in its gravitational potential energy is EP and increase in its kinetic energy is EK. What is the average power input to the mass? So first thing we need to understand is what is average power input. So I will write down average power input. That is equal to the total change in energy of the mass divided by time taken. Now imagine that we have the mass here. Let's say this mass is placed on the ground. Simply you can imagine like this. This has mass. Here it has kinetic energy initial that is equal to 0, and it has gravitational potential energy initial that is also equal to 0. Now we raise this mass vertically to certain height. At this certain height, the kinetic energy of this mass is Ek, plus it has also Ep. So this is the total energy of this mass at this point. So we can say this is Et, total energy of the mass, and this is also equal to the total change in energy of this mass. So we can say this is delta Et. So here 0 and the final one is Ek plus Ep. This is equal to the change in energy of the mass. So the power is energy transfer over time, or you can simply say the change in energy over time. So change in energy is Ek plus Ep, means mass has gained this much energy in this given time. So the answer for this question is D. Very straightforward question. Answer is D. For question number 19, it is given to us water flows from a lake into a turbine that is at a vertical distance of 90 meters below the lake as shown in this figure. The mass flow rate of the water is given that is equal to 2400 kilograms per minute, and the efficiency of the turbine is given that is 75%. We need to find out what is output power of the turbine. So very straightforward question. So simply we will start from percentage efficiency. So I will be writing here percentage efficiency. This is equal to useful power output. So useful P out. So simply we can say useful P out divided by total P in. For this question we need to find out useful power output. So simply we will write on here useful power output, or simply we can say P out. That one will be equal to the percentage efficiency. Here we have percentage efficiency times P in, and then we can calculate value of useful P out. So I will be writing here P out simply here. So the P out is equal to P in. First of all, we have to multiply with percentage. So this is 75%. So it simply means that 75 divided by 100 multiplied by P in, and P in is mg delta H over T. But in this question, m over T is given. So let me write on here. I can say this is 0.75, but m over T is given to us. M over T. We have to use SI unit. So we have to divide by 60. It means 1 minute has 60 seconds. So this is m over T. And G is 9.81 and the height is 90 meters. So if we solve this, our final answer should be 26 kilowatts. So this will be our final answer. So for this question, final answer is A. So simply you can also understand here. So here we have P in. So this is P in. So this turbine has certain efficiency, and here is P out. Question is asking us to calculate P out. For question number 20, it is given to us a wire of diameter small d and length L hangs vertically from a fixed point. The wire is extended by hanging a mass capital M on its end. The Young's modulus of the wire is capital E. Acceleration of free fall is G. We need to find out which equation is used to determine the extension X of the wire. So we will start by sketching, so you can get the clear picture of this question. Imagine that this is a fixed point and the wire is hanging from this fixed point, and there is a mass that is attached at the end of this wire, and the mass is capital M. The length of this wire is given, that is L. Young's modulus of this wire is given, that is capital E. Diameter of the wire is given, that is E. We will start from stress first of all. Stress is equal to the force exerted on the wire. We can say the tension in the wire. In this case, we can write down simply F over A. F is the tension in the wire, R is the force acting on this wire. So let me draw the free body diagram here. So if you look at this mass, the force acting down, this is the mg, and the tension in the wire is up. So tension in the wire in this case has to be equal to mg because this wire is not moving. So the tension is equal to mg. So simply we can write down tension in the wire is mg divided by cross-sectional area of the material. As this wire is a solid wire, so cross-sectional area of this one is pi by 4d squared. Now if we simplify this, we can write down stress is equal to 4 mg divided by pi d square. Now we need to find the relationship between Young's modulus, stress and strain. So simply we can say Young's modulus is equal to stress over strain. But strain is equal to extension over L naught. Extension in this case is X and the length of the wire is L. So this is strain. Now simply we need to plug in values. For stress we can write down this is 4 mg divided by pi d square. And this whole has to be divided by strain. And strain is simply X over L. Now if we simplify this one, we can write down this is 4 mg. This L we will multiply here and this will be divided by X pi d square times E. So this is how we can simplify. Now we need to find out value of X, means extension. So that will be equal to 4 mg times L divided by E times pi d square. So the answer for this question is this. So this is our final answer. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some typical type of questions on waves from Specimen Paper 1 for 2022 exam. For question number 21, it is given to us a wave has time period capital T and wavelength lambda and amplitude A. The wave is shown on a graph of displacement x against distance t. We need to find out which graph is correctly labeled. Now, if you look at graph A, in this case, you can see on x-axis we have distance and on y-axis we have displacement. So this one is the amplitude. Amplitude is the maximum displacement from the rest position. So this one is correct. And lambda is the distance between two identical points on the wave. Means the shortest distance between two identical points on the wave. That is called lambda. Or simply we can say it is the distance between two consecutive crests, or it is the distance between two consecutive troughs. So this is also lambda. We can also say this one is the lambda. The distance between two consecutive troughs, that is also lambda. So this is labeled right. So our answer for this question is A. Now if you look at option B is incorrect because this is time period. This cannot be time period. This can be lambda because x-axis is distance. So this one is wrong, but amplitude is labeled correct. So that's reason B is not answer. If you look at option C, this is also not correct option because this is labeled time period, but x-axis is distance. So it can be lambda, but it cannot be time period. If this is time period, x-axis has to be time. Now if you look at option D, in this case this one is correct, but if you look at amplitude, this one is wrong because amplitude is the maximum displacement from equilibrium. So this one is the amplitude, but this is 2 times of amplitude. So this option is wrong. For question number 22, it is given to us a vehicle emits sound of a constant frequency. A stationary observer hears the sound. The vehicle moves directly towards the observer at constant speed. The observer hears sound of frequency f0. The vehicle then accelerates. So we will take this one, case 1. Still moving towards observer. Travels at a higher steady speed for a certain period of time. So we can say this one is the second case. And then decelerate until it stops. So this one will be the third case. So we will say this is third case. Question is asking us what is the variation in the frequency of the sound that is heard by the observer. Now let's try to sketch the speed time graph for the motion of the vehicle. In this case we will sketch speed on y-axis. So this is the speed on y-axis and we have time on x-axis. For this question which is given to us, the vehicle is moving at constant speed and then it accelerates. So we will take initial speed of the car, means vehicle, v0, then it accelerates to certain maximum speed, then it continue moving at that steady speed for a while, then it finally decelerate to stop, decelerate to rest, means its final speed is equal to 0. And this is our case 1, and this one is our second case, and this one is the third case. Now we will look at all these cases one by one. First of all, we will discuss when the car is accelerating. So I will simply write down here when the car is accelerating and the speed Vs, this is the speed of the vehicle, means speed of the source. As it is given to us, speed of the source is increasing. Now we can use Doppler equation. F observed has to be equal to speed of the wave divided by speed of the wave, means speed of the sound minus speed of the source. And this one has to be multiplied with frequency of the source. In this case, Vs is increasing with time. If Vs increase with time, it means V minus Vs. This will decrease with time. If this decrease with time, it simply means that observed frequency will increase. Or simply we will say observed frequency will rise. So I will simply write down here. It will rise with time. So this is when the car is accelerating. Now if we go to the second case, for second case, it is given to us speed of the car is constant. So we will write down here speed of the car is constant. Again we check this. Again we can check this one with Doppler equation when the source is approaching. So we can use F0 is equal to V over V minus Vs times frequency of the source. In this case, Vs is constant. It means observed frequency will stay constant. So we can say is steady or it remain constant. Now let's try to understand what is happening in third case. For third case, it is given to us car is decelerating. It simply means that speed of the source is decreasing with time. So again we can use F0 is equal to V over V minus Vs times frequency of the source. Source is still approaching. That's the reason we are using V over V minus Vs. But in this case, Vs is decreasing with time. As Vs is decreasing with time, it simply means that V minus Vs is increasing with time. If this is increasing with time, it means that F0 is decreasing with time. So this is what is happening in third case. Now let's try to compare the frequency observed when the source is moving at speed V0 and the frequency observed when the source is at rest. We will say frequency observed when the source is moving at speed V0 F0 I, and the frequency observed when the source is at rest, we will say this is our final observed frequency. Now if we look at initial observed frequency, simply we can say F0 I, this is equal to V over V minus V0. V0 is the speed of the source and this is multiplied with frequency of the source. In this case, V0, this is greater than 0. So simply I will write down here, this is greater than 0. It means that V minus V0 is smaller than V. So we can say V minus V0, this is smaller than V. As this is smaller than V, so it simply means that this is smaller than V. So F0 I, this is greater than Fs. So we will say F0 I is greater than Fs. So observed frequency is greater than Fs. Now if you look at final observed frequency, F0 F, this is equal to V over V minus 0, and this is multiplied with Fs. So in this case, simply you can see this V will be cancelled with this V. In this case, final observed frequency is simply equal to frequency of the source. Final observed frequency is less than initial observed frequency. Very important point. We need this one. for the answer. Now, if you look at option C now, for option C, it is given to us observed frequency will rise, then remain steady, then fall to a lower frequency than F naught, means lower than F naught I. So this is true. So this is what is happening. We have rise, then frequency stays same, then frequency decreases to frequency of the source. And the final observed frequency is lower than initial observed frequency when the source was moving at speed v naught. So the answer for this question is C. D is not answer because this is telling us return to frequency f naught, not it returned to fs. So this one is wrong. So D is not right answer. First one is not answer. Fall, this is wrong. Fall, this is wrong. So A is not answer, B is not answer. For this question, it is given to us a car traveling in a straight line at a speed of 30 meters per second passes near a stationary observer while sounding its horn. The frequency of sound emitted by the horn is 400 hertz. Speed of sound in air is given and this is equal to 336 meters per second. We need to find out what is the change in the frequency of the sound heard by the observer as the car passes. It simply means that car is approaching observer first of all. So this is the first case. Car is approaching observer and then this car is moving away from observer. In this case, we need to find out what is the change in frequency. So the first thing we need to understand, when the car is approaching, we can find out observed frequency by observer. So F observed will be equal to V over V minus Vs time frequency of the source. And for the second case, when source is moving away from observer, we can also find out observed frequency. This will be equal to V over V plus Vs times Fs. But the question is asking us to calculate the change in the frequency. So we need to understand frequency observed when the source is approaching will be greater than frequency observed when the source is moving away. For approaching, so this is the case when it is approaching. So I will write on here approaching, in this case when the source is moving away. When the source is approaching, I will be using F naught A for approaching, and when the source is moving away, I will be using F naught F. Now simply we need to find the difference between these two. Delta F we need to find out. So I will simply write down F naught A minus F naught F. Now we can plug in values. F naught A we have this is equal to V over V minus Vs multiplied by Fs minus we have V over V plus Vs multiplied by Fs. Now simply we need to plug in values. Speed of wave is given. This is 336 divided by 336 minus speed of the source 30 meters per second. Frequency of source is given 400. And now we need to plug in values for speed of wave again when the source is moving away, and speed of wave in the medium means speed of sound plus speed of source, that is 30 meters per second. And this one we have to multiply with frequency of the source, and frequency of the source is 400. Now simply we need to solve this one. If we calculate in this case, our final answer will be equal to 72 hertz, and this is the change in frequency heard by this observer when the car passes this observer. So the answer for this question is C. Question number 24 is about electromagnetic spectrum. For this question we need to find out which list shows electromagnetic waves in order of increasing frequency. So first of all, let's try to understand electromagnetic spectrum. One way to remember electromagnetic spectrum is, you can simply remember Granny's Xbox. Granny's Xbox use volts in my room. Volts in my room. This is way to remember order of electromagnetic waves. G here for gamma radiations, or you can say for gamma waves. X here for X-rays. U here for UV means ultraviolet. V here for visible light. I here for infrared. So I for infrared, and M for microwaves. So M is for microwaves and R for radio waves. Now, if we go from radio to gamma waves, frequency of the waves is increasing and energy of the wave also increase. But if we go from gamma to radio waves, wavelength of the waves increases. But for this question, we need to find out in order of increasing frequency, means from radio to gamma waves. So if you look at option A, radio waves is right. After radio has to be infrared, then ultraviolet, then gamma. So this order is wrong. If you look at option B, we have radio waves. So the first one, we have radio waves. So the radio waves is here. Then we have infrared. Infrared is here. Then we have ultraviolet. So you can see ultraviolet is here. And the last one is gamma. Gamma rays. So this is in order of increasing frequency. So B is correct option. Now if you look at C, we have ultraviolet, then we have gamma, but again we have radio. So this order is wrong. So frequency is decreasing, gamma to radio. If you look at option D, ultraviolet, infrared, this is wrong. So this is going ultraviolet to infrared. Frequency is decreasing. So this order is not correct. That's the reason answer is D. For question number 25, it is given to us the diagram shows a steel wire fixed at one end. The other end of the wire is attached to a weight and the weight is hanging over a balloon. An oscillator is attached to the wire near the fixed end. A stationary wave with one loop is produced and the frequency of the oscillator is F. Which frequency of the oscillator produces a stationary wave with two loops? Now in this case we need to understand. Imagine that this is L of the wire. So simply we can say this is L of the wire, means the length of the wire from this point to this point. In this case we also need to understand this point is a node, this point is a node, and the distance between any two consecutive nodes or antinodes is equal to lambda by 2. So in this case lambda by 2, this is equal to L. So we can say lambda is equal to 2L. So this is how we can find out lambda. Now let's try to understand the second case when the stationary wave has two loops. So simply we need to draw two loops here. So imagine that here is an other node. So the first loop is this one. So we will have first loop here and this one will be the second loop. So we have two loops now. So in this case again we need to understand the distance between any two consecutive nodes is equal to lambda by 2. So distance from here to here is lambda by 2 and distance from this node to next node is also lambda by 2. So in this case L is equal to lambda by 2 plus lambda by 2. Or simply we can say L is equal to 2 times lambda by 2, or simply this is equal to lambda. Now in this case you can see lambda is equal to 2L, but now lambda is only equal to L. So it means lambda has been decreased, or lambda is half. Now if you get V is equal to F lambda, if lambda become half, it decreases to half. Frequency has to increase by 2. So the frequency has to be double. So that's the reason answer is C. Lambda becomes half, frequency increases to double, 2 times. For question number 26, we need to find out which statement gives a condition for diffraction to occur. First of all, let's try to understand a little bit about diffraction. What exactly diffraction is? Diffraction is simply spreading out of waves. So we can simply write down diffraction is spreading out of waves as they pass through a gap, or you can say hole. We can also say pass around an obstacle or an object. Pass around an object, or we can say obstacle or obstacle. So this is how diffraction is defined. Now let me show you this one with the help of figures. If you look at these two figures, you can simply see that in this case when these waves they pass through the gap, so we have these two waves here. As they pass through this gap, they spread out. So you can see they can reach behind the obstacle. So they spread out. So you can see this part is telling us they spread out. So now they can reach behind the obstacle. So this is telling us they spread out. They can reach behind the obstacle. So this is diffraction. And also we need to understand part of the wave is actually blocked. Part of the wave is blocked. Means this part of the wave cannot pass through the hole. If you look at this second figure, in this case you can see we have object, or you can say this is the obstacle that is in front of waves. So this one is the obstacle. This part of the wave, this one is blocked. Partially means part of the wave, this has been blocked, and the remaining part of the wave, this can pass through, and it's spread behind this obstacle. So this is another example of diffraction. This part of the wave has been blocked. Now based on these things we can find out the right answer. If you look at option B, in this case a wave is partially blocked by an obstacle, because this part of the wave has been blocked by this obstacle. So this is example of diffraction. Little bit tricky question, but this is one point you need to understand about diffraction. We can also say a wave is partially blocked by an obstacle, and this is the condition. You can see in this case part of the wave is blocked, and the part which passes through this gap, that's spread out. And the same is true here. Part of the wave means the wave is partially blocked, and the part of the wave which passes around this obstacle, that's spread out, and it can reach behind the obstacle. So these are few points we have to understand about diffraction. So that's the reason our answer for this question is this. For question number 27, it is given to us a parallel beam of light of wavelength 600 nanometer is incident normally on a diffraction grating. Grating has 300 lines per millimeter. We need to find out what is the total number of intensity maxima from the grating. First thing we need to understand, this question is about diffraction grating. So it simply means that we can use n lambda is equal to d sine of theta. Question is asking us about total number of intensity maxima. We have to consider angle 90 degrees. So this is one thing you need to understand. For intensity maximum, we have to use theta 90 degrees. And the second, we also need to understand sine of 90 degrees. This is equal to 1. Now from here, I can simply say n maximum on one side times lambda. This is simply equal to d times 1, because sine of 90 is 1. We need to find out n max. So the n max simply is equal to d over lambda. But well, if d is not given to us, grating has 300 lines per millimeter, so we can find out value of d. D will be equal to 1 over n. In this case, we have 300 lines per millimeter. So n is equal to 300 lines per millimeter. So means 1 mm per millimeter. Simply we can say 1 millimeter we have to convert into meters, SI units, divided by 300. Now simply this value of d we can plug in here. So d is equal to 10 to the power of negative 3 divided by 300, and this one is multiplied with 1 over lambda, and the value of the lambda is given. This is 600 nanometers, means 600 times 10 to negative 9. Now we need to solve this one for n max. If we solve this one for n max, our final answer will be 5.55. So this is value of n max, 5.55. We need to find out total number of intensity maximum. If you look at diffraction grating, so this is diffraction grating. Simply you can understand this is diffraction grating. Here we have screen. On this screen we will get center maximum. So n for this one is equal to 0. Then we will get another bright fringe. N is equal to 1, and here we will get n is equal to 2. Here we will get another intensity maxima, n is equal to 0, and 4 and 5. So we have calculated 5 on one side, but there also will be 5 on the other side, n minus 1. So here we will have n is equal to negative 2, n is equal to minus 3, 5 here. So n total, so simply you need to understand n total, this is equal to 2 times of n max plus 1, means 1 we have have at the center. So in this case, we have 2 times 5 plus 1. So we have total intensity maxima equal to 11. So the answer for this question is C. C is the right answer. For question number 28, it is given to us a pattern of interference fringes is produced using a red laser, a double slit and a screen. So first of all, let's try to sketch double slit. In this case, simply means that we have 2 slits and here is 1 screen. In this case, we will have 1 center maxima and will be equal to 0. Then we will have another maxima, intensity maxima, and will be equal to 1. So this is another bright fringe. Another bright fringe after this one. So this is n is equal to 2. Now we need to understand the distance between center to center of these 2 slits is called slit separation, and we use letter A for that. Slit separation. So let me write on here. So this is slit separation. And the distance between 2 bright fringes, this distance, this is x, and this is called fringe spacing. So let me write on here. This is called fringe spacing. Fringe spacing. For this question, it is given to us the screen is 3.5 meters from the double slit. It simply means that the distance between slits and the screen means this distance is given, and this is capital D. Capital D is equal to 3.5 meters. This one is over screen. It is also given to us the light from the laser has a wavelength of 640 nanometers. Lambda is given to us. The pattern of the fringes is shown. But if you look at this now, we have bright fringe, then we have another bright fringe. So the distance between 2 bright fringes, this is equal to 1x. So here we have another x. So I will be writing here another x. Here we have another x, and here we have another x. So in this case, simply you can see we have 4x. So we can say 4x is equal to 72 millimeters. So the value of x is equal to 72 divided by 4, and this one will be equal to 18 millimeters. So this is value of fringe spacing, and this is the most difficult part of this question. Most of the students, they cannot figure out value of x. So this is value of x. We need to find out separation of the slits. Means we need to find out what is value of a. For double slit, we need to understand ax is equal to lambda times d. We need to find out a, so it simply means that a is equal to lambda d over x. Lambda is given to us, that is equal to 640 nanometers. So we have to multiply by 10 to negative 9. D is given, that is 3.5 meters. So this is 3.5 meters. We have to divide by x. X is equal to 18 millimeters. Now simply we need to solve this one for a. If we solve this one for a, our final answer will be 1.2 times 10 to negative 4 meters. So the answer for this question is A. The main takeaway from this question is x is the distance between 2 consecutive bright fringes. So that is the main takeaway. Distance between 2 consecutive bright fringes is equal to x, and this is called fringe spacing. Welcome to A-Level and AP Physics. In today's lesson, we will discuss all electricity questions from Specimen Paper 1 for 2022 exam. For question number 29, it is given to us the diagram shows the symbol for a wire carrying current I. Means this is a wire and current in the wire is I. We need to find out what does this current represent. So first of all, let's try to understand what exactly current is. Current is equal to Q over T. And current, simply we can define current is the amount of charge passing through a point per unit time. Amount of charge. So Q is the amount of charge passing through a point per unit time. So Q is amount of charge and T is the time. So simply we can say current is the amount of charge passing through a point per unit time. Now if we have understanding of this one, simply you can see A is the right answer. The charge flowing past a point in the wire per unit time. For example, if you look at this point for 1 second, time is equal to 1 second. So the amount of charge passing through this certain point on this wire, if we divide that by time, we can find out value of current. So answer A is correct. Let's try to understand a little bit more about current. Now imagine that from this point, the amount of charge passing through this point in 1 second is 1 coulomb. Then current, simply we can say, means I, this is equal to 1 coulomb over 1 second. So this is equal to coulomb per second. And this is how we define 1 amp. Means 1 ampere is equal to 1 coulomb charge passing through a point in 1 second. If this is true, so current in the wire will be equal to 1 ampere. So in current, we talk about amount of charge. Now if you look at option B, this option is not correct because this is telling you the number of electrons. That in current, when we define, we talk about amount of charge. So option B is not correct. This is also talking about number of positive nuclei. Actually, positive nuclei do not move. Means ions, they do not move. So this one is also wrong. This is also talking about number of protons. This is also wrong because current is amount of charge per unit time passing through a certain point. For our next question, it is given to us an electric current I is given by the formula I is equal to A N V Q. Actually, this is transport equation. So let me write down the name of this formula. We call this one transport equation. Transport equation. Now question is asking us, what do each of the symbols represent for an electric current in a metal wire? Simply is asking you, what is A? A is the cross-sectional area. So A is cross-sectional area of the wire. N is the number density, or simply we can say is the number of free electrons per unit volume. So we can say is number of free electrons per unit volume. So this is what N is represented. Or simply we can say this is number density. So the N is equal to number density. We call this is number density because in this case we talk about number of free electrons per unit volume. But in simple density means the mass density. We talk about mass per unit volume. Now if you go to V, V is the average drift velocity of electron. Average drift velocity of electrons. So this is average drift velocity of free electrons. Q is the charge on single electron. Q is charge on single electron. Or simply you can say charge of electron. Charge on single electron. Now simply we understand the meaning of these symbols now. If you look at option B is the correct answer because this is area of cross section, number of free electrons per unit volume, and V is the average drift speed, average velocity, and Q is the charge of each electron. So B is the right answer. For question number 31, we need to find out which values of current and resistance will produce a rate of energy transfer of 16 joules per second. Rate of energy transfer simply means that power. Means we need to find out which value of current and resistance will give us power equal to 16 joules per second. Or simply you can understand this is 60 watts. Power, we need to understand power is equal to P is equal to I square times R. Now if you get given values of I and R, I will be just talking about option D. Rest you can just check by yourself. If you look at option D, value of current is given. This is 4 amps and resistance is 1 ohms. And this is simply equal to 16 joules per second. So our answer for this question is D. D is correct answer. For our question number 32, it is given to us a coil contains n turns of insulated copper wire wound onto a cylinder of diameter d. Diameter of the cylinder is given. It simply means that this is the diameter of the cylinder. So this is diameter of cylinder, and this is equal to capital T. The copper wire has diameter small d. So diameter of the wire is small d. Resistivity of copper is rho. Diameter capital D is much greater than diameter small d. We need to find out what is the total resistance between the two ends of the coil. So very straightforward question. So we can simply calculate R is equal to rho L by E. Resistivity of copper wire is given. So simply we can say this is resistivity. Cross-sectional area of the wire we can find out. That will be equal to pi by 4 d square small d square, because this is diameter of the wire. Now the problem is that how we can find out value of L. In order to find value of L, we need to find out the length of one loop of wire. And the length of one loop of wire, I will be writing here, length of one loop of wire. One loop of wire, that is simply equal to pi times d, means the circumference of the cylinder, pi d. So we can write down here pi d, but we have to multiply with n, because in the question it is given to us there are n number of turns. So we will write down here this is pi d times n. We can simplify this one. If you look at this, pi we can cancel with this pi, and we can further simplify. We can write down this is 4 rho n times d divided by small d square. Only difficult part in this question is to find the length of one loop of wire. If you can find this one, then simply you need to use R is equal to rho L by A. So our answer for this question is A. For this question, it is given to us two cells are connected to a load resistor of resistance 3 ohms. The electromotive force and internal resistance of each of the cells are shown in this figure. In this case, this is our load resistance. And you can see here we have two cells. EMF of one cell is 6 volts. Another cell has EMF equal to 3 volts. And these two cells, they also have internal resistance. We need to find current in the load resistance. Means we need to find out what is value of I. So the first thing we need to understand, these two cells are connected in series. So we can find out the net EMF. And also we can find out total resistance of this circuit, because all these resistors, they are connected in series. So simply we can say in this case I means current. This is equal to total EMF of the circuit. So we can say total EMF of the circuit divided by R total, means total resistance of the circuit. Total EMF is 6 plus 3 divided by total resistance 3.0 plus 1.2 plus 0.8. So this is simply equal to 9 divided by 5. So our final answer will be 1.8 amps. So the answer for this question is C. For question number 34, it is given to us the diagram shows a simple circuit. We need to find out which statement is correct. Actually, this question is based on internal resistance, and very common question. You will see this one in many past papers. Let's try to understand when the switch is open and when the switch is closed. What is effect on terminal potential difference? We will discuss case 1 when the switch is open. So simply I will write down here. First of all, when switch is open. When switch is open, there is no current in the circuit. As there is no current in the circuit, if we connect voltmeter here, let's say we connect voltmeter at this point across the terminals of power supply. In this case, reading on the voltmeter will be equal to terminal potential difference. And the second case, when we closed switch means when the switch is closed. When the switch is closed, there will be current in the circuit, means current will not be equal to 0. In this case, current is equal to 0 because voltmeter has very high resistance. So for ideal cases, we can assume that in this case, current is equal to 0. That in this case, current will not be equal to 0. Current will be greater than 0. So now if you write down the equation for EMF will be equal to the terminal potential difference plus V lost. From here we can find out terminal potential difference will be equal to EMF minus V lost. Or simply we can say in this case terminal potential difference will be less than EMF. Why is less than EMF? Because some of the energy has been used inside the battery or some work has been done against internal resistance. So that's the reason when we use battery for a long time, battery get warm because electrical energy is converted into heat inside the battery, means into thermal energy inside the battery. So some work has been done against internal resistance. So that's the reason when switch is closed, terminal potential difference is less than EMF. If you look at option C, it is given to us when switch S is closed, the potential difference across the battery falls. Decreases mean this terminal potential difference when the switch is closed. Actually, if you connect voltmeter here at this point or you connect voltmeter across this battery, reading will be the same, and that reading we call the terminal potential difference. And this terminal potential difference will be less than EMF because some work has been done against internal resistance. Now simply you can say in this case some of electrical energy will be converted into thermal energy. Now it is given to us because work is done against internal resistance of the battery. So this one is correct option. If you look at option A, it is given to us when the switch is closed, EMF of the battery falls because work is done against the internal resistance of the battery. The EMF falls. EMF does not change. So this one is wrong. If you look at second option, same is given to us. When switch S is closed, EMF of the battery falls. No, EMF remains same, but terminal potential difference decreases. Now, if you look at option B, when switch is closed, the terminal potential difference, the potential difference across the battery falls because work is done against the resistance of R. This is false. This is wrong. So the answer for this one is C. For question number 35, it is given to us 6 resistors, each of resistance capital R are connected as shown in this figure. The combined resistance of all these resistors is equal to 66 kilo ohms. We need to find out what is value of R. Very straightforward question. So this resistor has resistance R. The resistance of this one is also R. Resistance is R. Resistance is R. Resistance is R. And the resistance of this resistor is also R. Now if you look at the first resistor, so it has resistance R. If you look at combined resistance of these two resistors, they are connected in parallel and they have the same resistance. So the total resistance of these two resistors will be equal to resistance of one resistor divided by number of resistors. Now simply we can say this will be equal to 0.5. Now if you look at combined resistance of these 3 resistors, 3 of them they are connected in parallel. So the total resistance is equal to resistance of one resistor divided by number of resistors. Now if we simplify this one, we will get 0.33 R. Now you see we have 3 resistors now. Resistance of one resistor is R and resistance of the second resistor is 0.5 R and the resistance of third resistor, this is equal to 0.33 R. Now they are connected in series, so we need to find out total resistance. R total is given to us. R total is given to us, that is equal to 66 kilo ohms, and this is equal to 1.83 times R. From here we can find out value of R. Value of R will be equal to 66, this is kilo ohms, divided by 1.83. So the final answer will be 36 kilo ohms. So D is the correct answer. For question number 36, it is given to us a cell has constant electromotive force and constant internal resistance. A thermistor is connected between the terminals of the cell. The temperature of the thermistor is increased. We need to find out which statement about the change of the cell's terminal potential difference is correct. So first of all, let's try to sketch the circuit. In this case, we have cell. It has a constant EMF and and it also has internal resistance. So this is the internal resistance. And there is a thermistor that is connected between the terminals of the cell. It simply means that it is connected across the terminals of the cell. This is connected across terminals of the cell. So this is our thermistor. EMF of this cell we can say is E. So if we draw our cell, so this is what you will see physically. So this is the positive terminal of the cell. For this question, it is given to us, we increase temperature of thermistor. So when we increase temperature of the thermistor, resistance of thermistor, it will decrease. When resistance of thermistor will decrease, current in the circuit, it will increase, because current is equal to EMF of the cell divided by resistance of thermistor plus internal resistance. If resistance of thermistor go down, EMF is constant, so it means current in the circuit will increase. If current in the circuit increase, then we can simply understand EMF is equal to I times capital R plus I times small r. In this case, you can say this is terminal potential difference. So this one is terminal potential difference. So we can simply write down this is Vt, and this is equal to EMF minus I times R. For this question, it is given to us that EMF is constant, so this one is constant. R is also constant. If current increase, it simply means that Vt will decrease. So the terminal potential difference will decrease because work is done against internal resistance of the cell, same as we have discussed before. Now, if you look at option A, it is given to us the terminal potential difference decrease. So this is true. Why decrease? Because more work is done. Because more work is done due to more charge passing through the internal resistance. So that's the reason more work is done, moving the unit charge through internal resistance of the cell. So option A is correct. So this is correct option. If you look at option B, it is given to us terminal potential difference is decreased because current in the thermistor is decreased. Actually, current increased. So this is not the reason. So option B is not correct. Terminal potential difference increased. This is incorrect. Terminal potential difference increased. This is also incorrect. So the answer for this question is A. Terminal potential difference in this case decreases because current has increased. If current increase, it means more charge is passing through internal resistance. So more work has to be done. So that's the reason terminal potential difference decreases. For question number 37, it is given to us a battery with negligible internal resistance is connected in series with a resistor and a light dependent resistor LDR as shown in this figure. The light intensity of LDR is decreased. So the first thing we need to understand, when the light intensity decreases, if the light intensity decrease, resistance of LDR means R LDR, this will increase. So this is the first point we need to understand. If resistance of LDR increase, now we need to understand what is effect on voltmeter reading, means what is effect on VQ and what is effect on VP. This is what question is asking us. How do the readings of the voltmeters change? Let's try to understand what is the effect on current in the circuit. So we can simply say I is current in the circuit. So I we can simply calculate by dividing EMF of the cell by the total resistance. Mean resistance of P plus resistance of Q. Means RQ is the resistance of LDR. If resistance of LDR increase, it means current in the circuit will decrease. If you look at EMF and the potential difference across P plus potential difference across Q, EMF of the cell is constant. If you look at VP, so simply we can write on VP here. VP is equal to I time resistance of RP. In this case, resistance of resistor R is constant. So if I in the circuit decrease, it means VP will decrease. If VP decrease but EMF of the cell is constant, so it simply means that VQ will increase. So the potential difference across this one, LDR, will increase, but potential difference across resistor R will decrease. So based on this one, we can find the answer. If you look at option A, decrease, this is right. Decrease, this is incorrect. If you look at option B, voltmeter reading on P decrease, this is correct. Voltmeter reading of Q increase, so this is also correct. Answer is B for this question. Increase, this is wrong. Increase, this is wrong. So C is incorrect, D is also incorrect. So the answer for this question is B. Welcome to A-Level and AP Physics. In today's lesson, we will discuss some typical type of questions on radioactivity from Specimen Paper 1 for 2022 exams. For question number 38, it is given to us a radioactive nucleus is formed by beta minus decay. This nucleus then decays by alpha emission. We need to find out which graph of nucleon number N plotted against proton number C shows the beta minus decay followed by the alpha emission. So first thing we need to understand is what is nucleon number. Nucleon number simply is equal to mass number. Nucleon number also you can simply understand is equal to number of particles in the nucleus, or you can say is equal to the sum of protons and neutrons in the nucleus. So nucleon number simply is mass number. Proton number is equal to atomic number. So proton number simply is equal to number of protons in the nucleus. So proton number is equal to atomic number. Now we need to understand first of all what is beta minus decay. So I will explain first of all what is beta minus decay. Imagine that we have nucleus X, atomic number of this nucleus is Z and the mass number is A, and this nucleus decays to an other nucleus by emitting beta minus particle. So let's say the new nucleus formed is Y, and this is formed by beta minus decay. So here we have beta minus particle. So in this case, proton number will increase by 1, but nucleon number, means the mass number, will not change. So simply what is happening in this case is one neutron changes into one proton, but mass number remains same. So neutron decays into proton. In case of beta minus decay, neutrino is also emitted. This is fast moving electron. So this is particle. So here anti-electron neutrino will be emitted. So electron anti-neutrino will be emitted. So we have seen here in this case, proton number increases by 1. So I will write down here proton number increases by 1, but nucleon number does not change. So we can say nucleon number does not change. So nucleon number remains same. So I will simply write on here nucleon number does not change. Now let's try to understand what is alpha decay. So I will be writing here alpha decay. For alpha decay, we will also imagine one nucleus. Let's say this is nucleus X. Atomic number of this one is Z and the mass number of this nucleus is A. And this decays to an other nucleus, let's say Y, by emitting alpha particle. So this is alpha particle. So when alpha particle is emitted, atomic number decreases by 2 and the mass number, means the nuclear number, this is decreases by 4. So simply we can write out here proton number. In this case, proton number decreases by 2 and nuclear number decreases by 4. So simply we can write out here nucleon number decreases by 4. Decreases by 4. So if you look at option B, in this case you can see proton number increases by 1. So proton number increases by 1 plus 1. The nuclear number does not change. So this one is true. Now if you look at the second, so this one is beta minus decay. So this is beta minus decay. Now if you look at this one, in this case you can see proton number decreases by 2 and nucleon number decreases by 4. So this decreases by 2 and this decreases by 4. And this is true for alpha decay. So this is representing alpha decay. So our answer for this question is C. This one is the right answer. For question number 39, we need to find out what are the structures of the proton and neutron in terms of quarks. Simply we need to find out what is the right quark composition of proton and neutron. So first of all, let's try to understand what is quark composition of proton. Proton consists of 2 up quarks and 1 down quark. So this is quark composition of proton. So simply we can say this one is proton. And the quark composition of neutron is neutron consists of 1 up quark and it consists of 2 down quarks. So this is quark composition of neutron. So simply we can write down this one is neutron. Now if you look at option A, this is telling us proton consists of 1 up quark and this one is wrong. Next option is also wrong. But if you look at option C, it is given to us proton consists of 2 up quarks, 1 down quark. So this is right. But if you look at neutron, it is given to us it consists of 1 up quark. This is also right. It is also given to us it consists of 2 down quark. So this is also correct. So the answer for this question is C. So very important one you need to understand quark composition of proton and neutron. So proton consists of 2 up quarks, 1 down quark, and neutron consists of 1 up quark and 2 down quarks. For question number 40, we need to find out what is the charge of a top anti-quark. But there are total 6 types of quarks. Let's try to understand the charge on each type of quarks. In the first generation of quarks, we have up quark and we have down quark. In the second generation, we have charm quark and we have strained quark. In the third generation, we have top quark and bottom quark. If you look at these 3 quarks, means up quark, charm quark and top quark, all of them, they have the same charge. And the charge on them is equal to plus 2 by 3e. But now if you look at these quarks, means look at these 3 quarks now. We have down quark, we have strained quark, and we have bottom quark. All of them means all 3 quarks, they have the same charge. And the charge on them is equal to 1 over 3e. If you look at the first row, you can see up something higher, charm, also something better, top something higher. So they have the greater charge and positive charge. But if you look at down quark, down something not good, something low, strained also low, bottom something low. So they have the lower magnitude of charge and the charge is negative. So this is one way you can remember. Next thing we need to understand is anti-quark. Anti-quark has opposite charge. Anti-quark, for example, if we talk about anti-up quark, means up anti-quark, the charge on this one will be equal to negative 2 by 3e. If we talk about charm anti-quark, the charge on charm anti-quark will be 2 by 3e. And if we talk about top anti-quark, the charge on top anti-quark will be negative 2 by 3e. Now let's try to understand what is the charge on down anti-quark. So this is the symbol we use bar at the top. So this is telling us this is down anti-quark. So simply this one is down anti-quark. So this is down anti-quark. And the charge on down anti-quark is equal to plus 1 over 3e. Simply you can say just opposite charge. Now if we talk about strange anti-quark, so we will use this bar at the top. This is telling us this is strange anti-quark. And the charge on this one will be equal to plus 1 over 3e. Now if we talk about bottom anti-quark, so we will use the symbol for bottom quark and we will use this bar at the top. So this means this is bottom anti-quark. And the charge on this one will be equal to 1 over 3e. Simply you can see opposite charge. So here we can also use bar here, means this is up anti-quark and this is charm anti-quark and this is top anti-quark. And this question was asking us charge on top anti-quark. So the charge on top anti-quark is negative 2 by 3e. So the answer for this question is C. So it's very important if you can remember the charge on up quark, charm quark, top quark, and on down quark, strained quark, and also bottom quark. Then anti-quark simply charge is opposite.